Kirkham. I'm from the Science and Technology Facilities Council in the UK. And I'm going to be talking to you today about a European research project called PaaSage, and the main concept behind it, which is that you can specify an application once and really deploy it in any cloud. So the main objective of PaaSage is to create an integrated platform and prove that a set of methodologies and effectively hooked into existing cloud providers. We're targeting PaaSage software application developers, people who are wanting to put their applications on the cloud. We're also hoping that cloud providers might adopt some of our technologies to help people adopt the technologies. And we're also hoping that we can create a bit more flexibility in what we often do introducing into marketplace. PaaSage projects recently joined OW2, and all the PaaSage software is open source. We're working in collaboration with two of the EU projects listed there, Model Clouds and Artist. So here we go then. So the aim is to define the application goals and deploy it to any cloud. So the outline we'll follow is basically why we do this, how we deploy it, how we adapt it, and then it gets to the end. And it's funded by, as I mentioned before. So if you look at the software lifecycle, it starts off with the basic development area of software that is built and then deployed. PaaSage follows this approach, and we'll start with the development side of things. So when you're thinking about deploying your application on the cloud, we think about multiple different factors, and here's some examples. We're looking at different code artifacts, specific constraints, such as you want this level of memory, you want this level of performance on the cloud. And then also you may have some business-specific constraints which could express in policies, such as you only want it to run in the EU. And then the deployment decisions basically made on what cloud is chosen to run this application and the kind of architecture you use and the configuration. We also take into account market conditions with respect to cloud providers, such as the varying prices and different performances. We're also, as I move on to later, the social network where we can develop some form of trusted reputation about cloud providers. So PaaSage aims to basically get in all the constraints from the business angle, the application, critical application properties, and also the properties of the cloud landscape, and merge them into one specific area, which will be the model. So we will go, what's the model? So first of all, the modeling process, we create an application components. We identify the basic elements of the elements that's needed in order to support it. Then we have registered into the model repository the different providers which are available to PaaSage, and they have different characteristics. And then we model the different constraints, such as the service level objectives of the cloud provider, and the other aspects which might be specific to policies, such as location. Looking at the constraints is a significant challenge because things like availability are measured differently between cloud providers, and it's something that we try to make the model within our model. And then finally we define what happens when we reach the boundaries of these initially set metrics, such as memory or CPU, and how we can scale to suit that. And we stick all these constraints in one model, which we call CAML. This is the Cloud Application Modeling and Execution Language. Effectively, CAML is an overlay of different standards which already express our clouds and service-oriented architecture. So we're currently in CAML, we've put into a SRE, which is a standard to model roles within organisations. SRE, which models more or less cloud architecture. Scriptless agreement is used for SLAs. Cloud is coming out of the project as well through a Syntec, which is again an architectural-based modeling platform. I'm not sure what SLA is. Underpinning PaaSage as a software development platform, we use the Eclipse framework and we link that into the CDO module repository. So the core of the actual application deployment is the profiling and reasoning in PaaSage. The profiler basically takes the model and then basically puts it towards a specific problem. So problems taken from the model are then sent to our reasoning component, which looks at the current state of the cloud, i.e. what it's got in what terms, and then from that it defines a deployment model for the application. And then when the deployment has been run, the model is then passed to the adapter. So the adapter effectively controls the execution of the application in the cloud. So this component here, the execution engine, has specific drivers for different cloud platforms. So the initial user high-level requirements here, which are then filtered into specific problems and then used to separate different cloud providers, is then basically instantiated into the application executing. And as you can see, the execution engine is being developed to support different drivers, which are deployed onto different clouds. Monitoring is part of the execution as well. In this model, we basically probe the virtual machines in order to evaluate specific scalability rules, look at the service level objectives, but also restore the history of the execution. So when we go back to the reasoning steps, the knowledge can be reused. So the typical execution engine scaling operation will be linked to service level objectives and the threat of those being broken. If the scalability rules can be within the bounds, more VMs will be created and set on the cloud provider, but if it's outside of the bounds, the deployment is made. So typically we've got maybe 2 models which we have to fix based on the reasoning. So, it's models, it's clouds, and it's a lot of different metrics. And to be quite honest, it's basically quite hard to get your head around to use. So, if you're thinking about how you do it yourself, we've designed this social network called the PaaSage social network. And the idea on the social network is to create a community forum around modeling of clouds, and also developing drivers, etc., to deploy different platforms. These are some screenshots from the social network. The social network is based on Elm, which is an open source social network platform. It's a key motivation of it is for us to be able to share different PaaSage cloud models for people to use. If you want to have a go at the social network, which is probably your best start point to looking at PaaSage, just go to that link there and have a go at contributing. We're also doing a survey as well. So, PaaSage has got quite a high vision in the sense that it hopes to span different cloud providers. And we're hoping to do that through the models and being able to help develop the DevOps to create cross-cloud deployments. We're expanding the modeling capabilities of Camel by adding new domain-specific languages, just not the ones that are listed previously. And it's open source and it's supported by social networks, so we're open to embrace the community. And again, that's another reason why this session starts with a community. If you've got any questions, feel free to ask them now. This is our website, you can contact us, so give me a shout after that, we give you our contact details as well. They're also available on the slides. So, thank you. Any questions? Yeah.
Hello. Given that the PaaSage architecture being deployed to various cloud targets, such as FlexEdge cloud orchestrator platform, as well as open source type clouds such as OpenStack, do you think this shows that in a wider context then there's no barrier to proprietary clouds being used in wider cloud ecosystems?
In theory, using PaaSage, you can span these different cloud environments, so you can have a combination of proprietary and open source for your application. So, that could be more potential use of PaaSage. Any other questions?